My name is Rich Luick. I'm joined here today by Gennadiy Shafranovich, and we are both Android engineers at Peloton. Now, what is Peloton? Well, we like to say that Peloton sits at the intersection of fitness, hardware, and media. Our members can stream live and on-demand fitness classes from the convenience of their homes on both our bike and soon-to-be-released treadmill. Both platforms have an Android tablet running a custom OS based on the Android open source project. And as Android engineers, both Gennadiy and I are responsible for maintaining and improving the applications running on this platform. These applications include things such as a custom launcher, a background updater, as well as our main app, which you can see up on the screen here. And this is where you can stream those live classes. You can view your past performance on workouts, as well as view your live schedule, a lot of other things like that. So about 18 months ago, Peloton had 3 Android engineers, as well as a handful of other engineers on other teams like API, iOS, and web. Today, we have 20 Android engineers and over 100 engineers total. What we found out is that organizations need to work differently at different sizes. For example, the ideal workflow for a small team is going to be rapid delivery of new features. You want to get things out the door, and this is generally built in a more linear fashion, so you might have a handful of engineers working on 1 or maybe 2 projects at once. With larger teams, you have a lot more parallel delivery. So you have multiple teams working on multiple features all at the same time, and this is often on different timelines. Another example would be communication. Small teams, it's simple, it's direct, usually sitting near your other engineers as well as QA and product, and patterns sort of develop naturally. Larger teams, you get that direct communication maybe within your sub-team, but you got to remember that not just the Android team is growing, so is QA, product, API. So you're dealing a lot more with cross-team communication. And this kind of can lead to teams developing their own patterns. This can clash, and this can often prove to be a challenge. So, how do you grow while remaining efficient? Well, this is a core of what we're here to talk to you about today. If you're a large team or a kind of a small team transitioning to larger teams, this talk and process might be useful to you. If you're a small team, you might find this interesting, but be careful about not adding too much process early on, as this may slow you down.
So what we're going to be talking about is a flow that's at the heart of the process that let our team grow more smoothly. It consists of a few simple steps. You need to have a place where you can have discussions as a team. You need to we call it a town square. We have other names for it as well. You need to make decisions within that group. These decisions could be about the process within your team. They could be about your stack, whether a new library you want to bring in or something like that. You need to be able to communicate those decisions out to the rest of the team and the rest of the company. You need to have a built-in mechanism for enforcing these decisions, and you need to have a plan how you will iterate in order to adapt to changes. So what does the town square consist of? A town square is an inclusive venue. All of the members of your Android team or a larger team, if you don't have a lot of Android engineers at the moment, they participate. No question or issue is too small to bring up. If somebody has a little nitpick about a little code formatting thing, they should be able to bring that up, discuss it with everybody, and a change can be made. It needs to produce actionable decisions. This means that it applies to everybody. You can't have kind of like half your team follow the decisions coming out of your town square and have the team not follow those decisions. That will lead to chaos. As you hold your discussions, you will naturally produce action items within the town square. What this means is, work needs to be done. A lot of this time, this investigative work to dig down and to see whether this library is actually good or this formatting change, is it burdensome or not. This means they need to be assigned. A lot of times the volunteers will raise their hands. Usually people who suggested the change in the first place will raise their hands and they can pick up those tasks. But you need to hold those people accountable for that work. And your entire team is also tasked with communicating the decision because not everybody can make it to your town square every meeting. People have vacation, people have other meetings and commitments, people have work that's on short deadlines. So you need to be able to tell them why certain decisions are made. The why of your decisions are actually more important decision itself. because you need to be able to explain to people who weren't in the room why they should be making the change with the rest of you. And if you document, this helps a lot. So right after the decision is made, if you document it thoroughly, if you document the why, the what, and the when even of the decision, this helps in onboarding new personnel. This helps in communicating to people who were out. Your entire team is also responsible for enforcement. So this is the actual power behind this process, is enforcing decisions you've made as a team. It builds trust. It means people are heard. It means that your team is actually moving forward with the stack and with their internal processes. Here's another example where partial enforcement, just like the decisions having to apply to everybody, the enforcement needs to apply to everybody. Partial enforcement is as bad as zero enforcement. If you have exceptions within the team, or you say, oh, this sub-team does not need to follow this new guideline because of X, Y, and Z, this is actually even worse. It creates multiple tiers within your team and leads to trouble down the road. You should use tooling wherever possible to enforce your decisions. So if you have decisions that are either linting, code formatting, things that can be automatically enforced, do so. Put tooling into your CI, put extra things into your GitHub to make the enforcement easier. Where that's not possible, the entire team should be doing the enforcement through code reviews. This means that somebody will send out a PR, they will get a pushback saying, hey, we all decided we're going to be using this new technique or this new pattern or this new library going forward, please use this. Most likely you will get pushback on your comments saying, why should I do this? And this is where your communication and the documentation you've made during communication phase becomes super important, because you'll be able to point to your piece of documentation and say, hey, here's why we're doing this as a team, and here's why it's important. So what keeps the process dynamic is the last portion of it, which is the iteration. You need to iterate because your environment will change, your requirements will change as your company grows, and as you pick up more and more kind of things that need to be done, as more, the team gets larger and the requirements get more complicated. Your staff will change. You will hire people from various backgrounds. They will bring in their expertise, and they will want to contribute to your stack. They will want to contribute to your process. You need to iterate on your previous decisions and hear them out. Your ecosystem will change. Most recently, we all experienced this, switching over from Java to Kotlin. As a team, you will need to make these kind of decisions and be able to iterate. Before you said, oh, we're using Java 8 formatting. Here's where we're going. Kotlin comes up, you need to discuss that. When things change, what do? You use your town square. You surface the issues, problems, anything that you've seen with your previous decisions. You surface suggestions for new frameworks, new libraries, new formatting rules, anything pretty much in your town square. You iterate on them, you question your previous decisions, and that's how you iterate. You want to make sure that you don't wait for a perfect outcome from your decision before it's actually in place. If you're in a position where you can make a change that improves your current stack or improves your current process, do it now. Making a small change now and making another small change will lead to a good cycle of iteration and will lead you to a much better process and stack down the line. And remember, no decision is actually final. If you're in a conversation and somebody says, hey, why are we doing this? Why are we following this guideline? If you do not have a good answer to that question, it may be time to iterate. It may be time to come back and say, why, is this still valid? Do we still need to use this thing? This includes decisions that were a no originally. So if as a group something got brought up, you discussed it, you decided, no, we're not doing it this way for now. 3 months down the road, the ecosystem might have changed. The library that was being suggested might have gotten more stable, more community support. It might be worthwhile to revisit your no decisions and see if they become a yes maybe, and may improve your team and your productivity. This also includes the process itself. So use your town square to iterate on the process. You keep what works, you throw out what gets in the way. If somebody says, hey, there's too many steps in a certain piece of process, iterate on that, bring it up, discuss it with your teammates, and you will come to a good outcome, in the end.
All right, so let's now take a look at how the town square works at Peloton. So we actually call our town square Android Matters. And this is a weekly open meeting where all engineers are encouraged to participate. So it's everyone from junior level to senior level. And we make sure we always have a pre-meeting agenda. So in between meetings, a doc is created, similar to the one you can see up on the screen. And all team members can contribute to this with agenda items. Now, if the agenda is empty, we can cancel the meeting. We don't want to waste people's time, but usually we find that there's at least a few things to talk about week to week. And some of these agenda items could be anything from small things to maybe issues with your continuous integration environment, unit tests, all the way up to larger things like introducing a new library to your code base. And we always make sure we follow a set template in these meetings. So first thing we do, we review the action items from the previous week. We close out ones that are completed. We roll some forward that need further investigation. And this is a good point to hold people accountable for completing the action items assigned to them. Moving on, we go to the agenda items that were added during the week. A lot of times we can make decisions on these agenda items in the room if they're a little smaller. But a lot of times there's much bigger or much more discussion that needs to happen, more investigation. So this is where we actually assign action items and owners to people to investigate further. And again, we only take as long as we need in this meeting. So we usually budget for about an hour a week, but if you're done in 15 minutes, everyone's free to go from there. So I think I'll show an actual example of how we put this to use, specifically deciding on new architecture. So for a while, we're using the model view presenter pattern in our code base. It worked well for a little bit, but after a while, some engineers noticed some limitations with this pattern. So during the next town square, this was discussed, and a potential solution was brought up to kind of move to a new pattern. In this case, model view view model. So pros and cons are discussed. What will we gain from this? Will be faster development, improved readability, improved performance. On the flip side, is there a big learning curve, a big refactoring cost? So this is a brand new architecture pattern after all. So this is definitely something that's too big to make in a 1-hour meeting. So action items are created to investigate this through a proof of concept to kind of help demo how this might look. This could be a sample app, something simple with a few features, but even better, actually a refactoring an existing feature using this pattern. It's a better way to demonstrate how this will look in our code base. And one last thing to always remember, we have to keep things transparent here. So product and management were notified of what we were doing, as well as other stakeholders. It's very important we communicate decisions like these. People need to know what we're up to and why we're doing it. All right, fast forward to another town square meeting. MVVM was actually shown to be beneficial for our code base based on the findings from the proof of concept. So a decision was made to use this for all new features. We created documentation describing the approach to help with the rollout of this pattern. It's a good reference for people kind of ramping up on this new pattern. And we also enforced through code reviews. Specifically, engineers who worked on the proof of concept or were already familiar with the pattern were required as reviewers from the start. And this really helps onboard others who are less familiar with the pattern. You get kind of instant feedback on some of your code, which can be very helpful if it's something new to you. So what happened? Well, as we rolled out, we had some early successes. It worked really well for some screens like our auth or login flow, a lot of linear screens where you might have one button, an action, and you kind of move on to the next page. We started to see some issues, however, on higher density screens. For example, we have an image of our performance screen up there. It's pretty elaborate. There's a lot of data being displayed on this screen. We have user information, all this workout data, graphs. You can also change users to view other users' profiles. And this is where we started to run into issues. We had some synchronization issues with state when we changed users. Some things might have been a little stale or slow to update. And the internal navigation on the left made this a little more difficult. And what made it actually worse was we had 8 engineers working in parallel. So we were all very modularized and focused on specific areas. We kind of missed some of the bigger issues, at least early on.
So yeah, as we said before, when you hit a speed bump with your previous decision, you got to iterate. So how do we do that? We use the same process from the beginning. And we started over with a discussion. So we had somebody we have a few people bring up the issues we saw on the denser screens in our town square meeting. And the conversation started. It's like, is MVVM actually the real problem behind the symptoms we're seeing? Are there any short-term fixes we can put in so the 8 engineers who are going at very high speed can continue to deliver on their feature, and we can kind of come back to it later? A higher level question got raised: is there a unified pattern that can fit some of the simpler use cases, some of the stuff that we had success with MVVM with, and these other use cases that are high, the high density screens where we have synchronization issues? And finally, we realized, kind of after 10-15 minutes of going back and forth in the room, nobody actually had a proposal to fix anything, right? It was more like, this is a problem, why don't we do it this way? Oh no, that's going to be a problem. So we kept bouncing. As soon as we realized that this was a sticking point, the proposal became, hey, find a pattern that fits our use cases. And we can't do that in the room. So what do? We, kind of 2 volunteers that are on stage stood up and we said, okay, we can take the work to investigate and see if there's a unified pattern that can fit. That can handle the current work, can handle the future work. We set out to test a representative example of what's in the app. We didn't want to just, everybody who comes up with a pattern or tests out a pattern ends up using this decrement increment app, which is very, very simple, has very simple data flows. We said, no, we have to sit down, take the flows we know are complicated within our app and the ones that are easy, and make proof concept apps out of those representative examples. They don't have to be pretty, they don't have to be fully feature complete, but they have to work in the same way they will work in our main repo. So we also listed out a bunch of frameworks we wanted to test. So we wanted to test kind of what would happen if we added MVI into our model view model setup. So we tested out Grox, we tested out Mobius. We said, okay, maybe the problem is actually the way we wire model view model. So we tested out Mosby. All the while, we were also working through a homegrown approach with all the learnings taken from the various framework tests, with the experience we had with MVVM internally, different blog posts, and so on and so forth. We also formed an advisory group around the 2 volunteers to help them make decisions. 2 people is rarely enough personnel to make solid decisions, because you can have a disagreement very easily and you don't have a tiebreaker. So we formed an advisory group of senior engineers around that volunteer group that they can rely on to say, hey, we're thinking of doing state this way, what do you think? And get immediate feedback, not wait for the next town square. And we time boxed the effort to about 3 weeks. So it's like, in 3 weeks, we don't need to build a thing, we just need to figure out if a pattern is out there that fits our representative use cases, and if there is, what is it? And if once we know what it is, what is the plan to actually bring it into the code base and ramp it on? And the idea was to take all of this investigative results, bring it back into the town square, and have the larger discussion again once we know more. And that is exactly what happened. Once we had more information, we were able to bring that back in, share it with our teammates, and make an actual decision. One of the first things that the volunteer team realized and brought back to the advisory group and then brought back to the larger group, even before all the tests were complete, was that the problem was not model view model. The problem we encountered on the dense screens was actually an issue with data flow. We did not have unidirectional data flow, and that is where pretty much 90% of the data synchronization issues and state synchronization issues came from. Multiple components would try to emit state at the same time. They would try to mutate some kind of shared state somewhere. One would get overridden, you lose it. The usual story of non-unidirectional data flows. So we looked at unidirectional data flow as a guide and MVI as a pattern as a fix. And we said, okay, it will fix our dense screen problem, and it's not too much of a burden for some of our simpler screens and the rest of the app. So we said, okay, let's go with MVI on top of MVVM. Should we use a framework? We took all the information and all the learnings we had from the proof of concept experience over those 3 weeks, and we said, none of the frameworks fit perfectly, but the one we developed along the way during those 3 weeks is a very good fit because it was custom made for us in our use cases. So we decided to use our homegrown framework going forward. And this was a decision as a team. So we said, okay, everything being built going forward should be built using this framework. As always, as we said in the beginning for this process, we said we need to communicate and enforce. So we fully documented the framework itself. This includes comments and Confluence page to kind of explain how a new feature is to be created using the new framework, and not a simple, again, not a simple increment, decrement. We said, okay, if you wanted to display this highly complicated piece of information that merges from two separate global states, how do we do it in this feature? We provided a tutorial, provided pairing session time for people ramping up on the framework. Just as in the original model view model adoption, we used code review as the main enforcement tool, mainly because it's a pattern. You can't really automate enforcements of patterns very easily. So we relied on the original volunteer group and the advisory group to be mandatory reviewers in the beginning. And like I said, also making sure there's pairing time and design pairing time where we can sit down with one of the Android subteams, figure out what their state looks like, what their flows look like, what their modularization should be using the new framework, what the component separation will be, help them kind of plan it out, and then also be available for any questions that come up. What came out of it is this framework we don't actually have a name for yet. It is written in Kotlin. This was an interesting detail. It's not just, we're not just putting up here because every other talk in this droidCon is Kotlin talks. What happened was about 3 weeks prior to the decision on the architecture, there was a similar discussion in the town square about Kotlin. Should we adopt Kotlin as a team? Should all new features going forward be written in Kotlin? So on and so forth. As that process went through, the team did decide that all new work should be done in Kotlin. And the framework is no exception. So we actually kind of like pulled the brakes on the second week of those 3 weeks we had, and we took all our base classes and all of our utility classes, and we just rewrote them in Kotlin straight there because we knew we had to deliver in Kotlin towards the end of it because the team was expecting it. So the framework itself. The framework is meant to supplement model view model, not replace it. We took our learnings from using model view model for about 8-9 months over various use cases in the app. We removed a bunch of boilerplate that's required for it, basically providing some base classes for view models. We try to stay as far away from providing base classes for the actual view components as possible to allow you to have your own hierarchy of activities, fragments, and custom views, and so on and so forth, so we don't interfere with existing hierarchies. We standardized some of the method naming, like do you call your method render or onState received or show me a thing, like what do you call the standard method to render state once it's received in your view component. We eased some of the wiring and some of the lifecycle management issues, similar actually to what MVRX was the Airbnb was talking about when they were discussing MVRX. It relies on global app state, which very, very similar to the Redux Flux model. So there's a single source of truth for all your data within the app. It sits kind of in this global memory state. It is managed by a global store as provided by the framework. The way that works is components dispatch actions. The actions act as reducers, and they mutate the state, and then the newly kind of mutated state gets emitted to whoever's subscribing and observing it. It is based on reactive state consumers, and this is a fancy name for I have my fragment, or I have my activity, or I have my custom view. It subscribes to state changes or substate changes, and once it receives them, it just says, I need to render these 4 pieces of data, go and render them, and it does that. And then we made sure that we build it in an expandable fashion. So because the model is very similar to Redux and Flux, we were able to very easily integrate it with Redux DevTools, which is actually a screenshot you see on the right. That's out of the POC app that's actually coming straight out. So a Kotlin JVM-based runtime is delivering state and action flows into Redux DevTools, which was, I think, 50, 60 lines of code or something like that. It was relatively easy. We're planning more extensions in the future, similar to how Redux does extensions through middlewares. And part of the original decision that was made in the town square was to make sure that when we created this framework, it was built with open sourcing in mind. So because of that, we're hoping to sometime in 2019 to actually have it up on GitHub in a public repo and for everybody to be able to use it and contribute. Right now, we're just testing out internally, making sure we shake out all the bugs before we deliver it to everybody else.
Awesome. So what are some of the benefits of this process? Well, in addition to being able to develop our own framework in-house, we've been able to roll out a few other big things using this process. So as Gennadiy actually mentioned, we did use this for Kotlin, as well as RX Java and Android architecture components. There's also a lot of smaller things you can kind of roll this out, lesser known, that are just as useful. So one thing we use for code formatting is the Google Java Format plugin. And this basically will auto-format your code on each commit to Google standards. Helps keep the code base consistent. Another thing is the concept of code ownership. So actually on the bottom, you can see a code owner file. This allows you to assign owners to specific files or directories, usually people who are experts in that area of the code base. This will actually automatically assign them to any pull requests if any of those files or any files in those directories change. It really helps give visibility to people that might be interested in seeing those pull requests. Another thing in the top left is pull request labels. A pretty simple idea, but basically allows you to label pull requests with certain technologies. This one's actually a Kotlin label, so if you see that this is a Kotlin pull request and you know a lot about Kotlin, you might be interested in having a look. Top right is a GitHub integration called Danger. This allows you to add custom rules that can show warnings on your code reviews. For example, we have a recommended pull request size of 500 lines, so if you change more than that, you'll actually get a warning here. It can kind of remind you to keep it smaller next time. And there's many more things you can do here. We've rolled out all of these using this town square process, and yeah, the possibilities are endless. There are some considerations though. So number one is very large teams. So we've scaled this successfully up to 20 engineers, and it's worked well between 5 and 20 or so. We haven't yet tried this with a very large group. And as we grow, we're kind of considering splitting this up into maybe more concentrated town squares. That way, we don't have a lot of people in one room at one time. The second thing is minority opinions. Remember, everyone needs to be heard. This is actually a really important part of the process. However, not every suggestion is right for our code base or our team. So we need to make sure there's always a good explanation of why not. We need to explain why this suggestion isn't right for our team. The third thing is action items with no progress. The team can lose trust in the process if there's no forward movement on action items. So we need to make sure we hold people responsible for their action items. This is why this is the first thing we kind of start each town square meeting off with. Last thing, things take time. The meetings, the work, proof of concepts, this all takes time. So make sure the rest of the company buys into the process and is aware of what's going on. In the end, though, it's all worth it. This process has let us adapt to a growing team with changing requirements in a very volatile ecosystem. All the while, we've been able to deliver consistent, high-quality work with a low defect rate. We have a much healthier team. Everyone is heard, and engineers are empowered to push for positive change. This has given us a clear process to improve and learn. All right, thanks everyone. Like everyone else here, we're also hiring, so please hit us up if you're interested. We are based right here in New York, and we do have a booth out front, so feel free to stop by if you have any questions.